Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you and your family in the best of health. Congratulations to you all on your promotion in grade 10. I have complete faith that inshallah, this academic year will be the best of all. Welcome back and best wishes for this new academic year. Dear students, this lecture is for grade 10, subject chemistry, lecture number 1, and here is Mrs. Saira Jamal. Table of content, the chapters which you will study in this grade, they are chapter number 9, in continuation of the chapter numbers from grade 8. We have learned 8 chapters in grade 8. And the remaining 8 chapters, inshallah, you will learn in grade 10. Starting from chapter number 9, which is about chemical equilibrium. And chemical equilibrium is related to the branch of chemistry, that is physical chemistry. Chapter number 10 is about acid, bases, and salts and is related to inorganic chemistry. Chapter number 11, Organic Chemistry, related to organic compounds. Chapter number 12, Hydrocarbons, again carbon containing compound, so related to organic chemistry. Chapter number 13 is about biochemistry. Chapter number 14 is about atmosphere, related to environmental chemistry. Chapter number 15 is about water, quality of water, purification of water, so analytical chemistry. Chapter number 16, chemical industries related to industrial chemistry. So these 8 chapters, inshallah, you will study in grade 10, and these chapters are related to different fields of chemistry. Coming towards chapter number 9, which is chapter number 1 of grade 10, it is about the chemical equilibrium. What are the major concepts which we will study in this chapter? They are reversible reactions and dynamic equilibrium, law of mass action and derivation of the expression for the equilibrium, equilibrium constant and its units, and importance of equilibrium constant. All these concepts, inshallah, you will learn in this chapter. Introduction of this chapter. What is chemical reaction? Before going into the detail of chemical equilibrium, you must know what is chemical reaction. A process in which one or more substances, which are called reactants, are converted into one or more substances called the products. A process in which the reactants are converted into products is called a chemical reaction. For example, a reacting substance A, when react with another reacting substance B, they will react together and will form product C and D. So two substances react together and will form two products. A and B are the reactants or reacting substances. C and D are the products or the substances which are formed after the reaction of reacting substances A and B. In this image you can see the pink balls are atoms of reacting substance A and blue balls are the atoms of reacting substance B. They will react together and will form two products Yellow balls are for the C and green balls are for the substance D. So A plus B are the reactants or the reacting substances. They will react together and will form product C plus D. Types of chemical reaction. There are two types of chemical reaction: reversible reaction and irreversible reaction. There are two types of reactions: reversible reaction and irreversible reactions. What are irreversible reactions? In an irreversible reaction, the reactants react to form the products which cannot revert back into a reactant. In simple words, you can say the reaction which cannot be reversed or which cannot be revert back is called the irreversible reaction. For example, A when react with B will form C plus D, but C plus D cannot give back the A and B. Such type of reactions are called irreversible reactions. A reaction which proceeds in the forward direction as well as in the reverse direction under same condition is called reversible reaction. It means that the reversible reaction is bidirectional. It means it can proceed in forward as well as in reversible direction. But irreversible reaction is unidirectional. It proceeds only in the forward direction and reverse reaction is not possible. While in case of the reversible reaction, forward reaction as well as reversible reaction is possible. Or in simple words, a reaction in which the products can react together to reform the original reactants. The reactants will react together to form product. This is called forward reaction. Reactants react together to form product is forward reaction. And the product C plus D are the product. You can see in the second reaction C plus D, the products will react together to give back the reactants which are A and B. This is called reverse reaction. Reversible reactions never go to completion because when the product is formed, the product is converted back into the reactant. Then reactants again converted into product, then product again into reactant. So these two reactions continue. That's why reversible reactions never go to completion. Irreversible reactions, those type of reactions they go to completion, but reversible reactions never go to completion. It is represented by double arrows. Reversible reaction we represent by putting these double arrows. Differentiate between reversible reaction and irreversible reaction. It can be reversed under suitable conditions. Definitely by providing specific conditions. Condition mean temperature, pressure, and use of catalyst. These are the conditions. So by providing suitable condition, the reaction can be reversed. Means the product can be converted back into the reactants. But irreversible reactions cannot be reversed. Reversible reaction, both forward and backward reactions takes place simultaneously. Simultaneously means at same time. At same time, in same experiment, reactants are converted into products and products are converted into reactants. While irreversible reactions are unidirectional and it proceed only in forward direction. Reverse direction or reverse reaction are not possible. It attains equilibrium. A special type of state is attained in reversible reaction. That state is called equilibrium state, while an equilibrium state is not attained in irreversible reaction. About equilibrium, we will discuss in the next topic. The reactants cannot be converted completely into products because I told you that the products are converted back into the reactant. That's why complete products cannot be obtained. But in case of irreversible reaction, the reactants are completely converted into the product. Reversible reaction is a slow process because it is multidirectional, or you can say it is bidirectional. Forward as well as reverse reactions are possible. While irreversible reaction is unidirectional, so it is fast. So reactions are converted into the product at a faster rate. Examples of irreversible reactions: potassium chlorate after heating. Thermal decomposition means, thermal means by heating. Potassium chlorate, by heating it decomposed or it breaks down into two molecules. Those two molecules are potassium chloride and oxygen gas. So once potassium chloride decomposed into potassium chloride and oxygen gas, what happened? This potassium chloride and oxygen gas, they cannot combine to form potassium chloride back. In case of irreversible processes, the change occurs only in forward direction and the process is acquired completion, means the reaction is completed. When potassium chloride after heating decomposed into potassium chloride and oxygen, oxygen is a gas, it will evolve out. So potassium chloride cannot react with oxygen to give back the potassium chloride. So this type of reaction is called irreversible reaction and it is a complete reaction. Examples of reversible reactions are, first example is oxidation of sulfur dioxide. Sulfur dioxide react with oxygen and will form sulfur trioxide. This double arrow you can see is for the reversible reaction. Second example is formation of ammonia. Ammonia is formed or prepared by reaction of nitrogen gas with hydrogen gas and will give ammonia. Nitric oxide react with oxygen, or in other words, oxidation of nitric oxide will give nitrogen dioxide. 2 moles of nitrogen dioxide, 2 moles of ammonia are formed, 2 moles of sulfur trioxide will form. From 2 moles of sulfur dioxide, from 3 moles of hydrogen, and from 2 moles of nitric oxide. These are the conditions which I told you that at suitable condition mean at suitable temperature, suitable pressure and catalyst. You can see for the suitable condition for this reaction are temperature is 450 degrees centigrade and pressure is 200 atmosphere. Catalyst we use is vanadium pentaoxide. The condition for this reaction are 400 degrees centigrade temperature, 200 atmospheric pressure, and in the presence of a catalyst, iron. And this reaction will take place in the presence of electric spark. It means during thunderstorm. What is equilibrium? Equilibrium or chemical equilibrium is a state in which the rate of the forward reaction is equal to the rate of backward reaction or the rate of reverse reaction. Types of chemical equilibrium, there are two types: static equilibrium and dynamic equilibrium. Static equilibrium is also called mechanical equilibrium, and it occurs when all the particles at equilibrium state are at rest and there is no motion between the reactants and product. At equilibrium state, the reaction is completely stopped. There is no continuation in the reaction, or in other words, you can say that uh, reaction is the product is formed and the reactants are also formed at final level, and now the reaction is stopped. There is no more change in the concentration of the reactant and product, and even at molecular level the reaction does not take place. Example for static equilibrium is turning of graphite into diamond. In dynamic equilibrium, the reaction does not stop, but it continues at molecular level. Molecular level means at very small level or at microscopic level. At macroscopic level or at big level or the level which we can see through the naked eye, it seems stop, but at molecular level or at macroscopic level the reaction continues. In other words, there is no net change in the concentration of reactant and product, but still the reaction is going on in both directions. The reaction is continuous. It does not stop. So this kind of equilibrium is called dynamic equilibrium. At static equilibrium, the reaction stop. It does not take place at microscopic level or at molecular level, but at dynamic equilibrium, the reaction does not stop. It continue at molecular level or at microscopic level. Dynamic equilibrium means a state of balance between continuing process. A state of balance, I told you, is the forward reaction and the reverse reaction. The rate become same. Example of dynamic equilibrium is you can see for the equilibrium to establish, the first condition is closed system. Closed system is compulsory. Closed system means you can see this glass having a cork on its mouth. It means this is a closed system because the liquid inside the flask cannot escape out, or the matter inside the flask cannot escape out due to this cork. So this is a closed system. For equilibrium to establish closed system is compulsory. Now in this closed system you can see we have liquid water, and the liquid water is converted into vapor. This process of conversion of liquid into vapor or into gaseous state is called evaporation. So you can see initially at the start more vapors are formed. So it means that the conversion of liquid into vapors or the rate of evaporation is very high at the start of the reaction. But after some time, what will happen? The vapors will then convert it back into the liquid state because they cannot find any way to go out or to escape. So they will convert it back into the liquid state and then enter into the liquid. So this conversion of vapors into liquid is called condensation. Conversion of liquid into vapors is called evaporation, and the reverse reaction, conversion of vapors back into the liquid water, is called condensation. So forward reaction is evaporation and reverse reaction is condensation. Initially I told you that the rate of evaporation was high, and then after some time the rate of evaporation decreases and rate of condensation increases. But we reach at a point when the rate of condensation becomes equal to the rate of evaporation. That state is called equilibrium state. And I told you that the equilibrium state in which the molecules does not stop, they continue at molecular level or at macroscopic level. So this equilibrium is also called dynamic equilibrium. Example of dynamic equilibrium or example of reversible reaction, because I told you that equilibrium is established only in reversible reaction. I told you in the differentiation between reversible and irreversible reaction that this state or equilibrium state is established only in reversible reaction, because this is the property of the reversible reaction that they attain a state called equilibrium state. And I told you equilibrium state means when the rate of forward reaction become equal to the rate of reverse reaction. In this case, you can see oxidation of sulfur dioxide to form sulfur trioxide. Forward reaction is conversion of sulfur dioxide into sulfur trioxide, and the reverse reaction is sulfur trioxide molecules will react with each other and will convert it back into the sulfur dioxide and oxygen. So this arrow you can see from left to right is for the forward reaction, and this arrow from right to left is for the reverse reaction. So reactants are sulfur dioxide and oxygen, which are converted into product which is sulfur trioxide. But the conversion of product back into the reactant is reversible reaction. The forward reaction, and this one is the reverse reaction. And at equilibrium state, what will happen? We will reach at a state when the rate of forward reaction becomes equal to the rate of reverse reaction. And at this state, at equilibrium state, very important for MCQ's point of view, that in most MCQ they ask that at equilibrium state which types of molecules are present. Either only reactants are present, or either only products are present at equilibrium state. So the correct answer is that at equilibrium state, all the molecules of reactants and products will be present. You can see that at equilibrium state, these two red balls are for the oxygen molecule, and these three balls, one yellow and two red balls, are for sulfur dioxide. And this molecule having one yellow and three red balls are for sulfur trioxide. It means that at equilibrium state, all the molecules of reactants and all the molecules of products will be present at equilibrium state. So at equilibrium, all three types of molecules are present. Molecules of sulfur dioxide and oxygen, which I told you, will react together to form sulfur trioxide. And this is the first reaction. You can see sulfur dioxide will react with oxygen to form sulfur trioxide. And this is forward reaction, and it proceeds from left to right. Reverse reaction is the sulfur trioxide when converted back into sulfur dioxide and oxygen. This is reverse reaction, and it proceeds from right to left. But at equilibrium state, you can see the double arrows, which shows that the sulfur dioxide react with oxygen to form sulfur trioxide, which is forward reaction, and sulfur trioxide then converted back into the sulfur dioxide and oxygen, which is the reverse reaction. Which reaction is forward reaction? The first reaction is forward reaction. And which reaction is called the reverse reaction? The second reaction is called the reverse reaction. Initially, at the start of reaction, there is no sulfur trioxide, because we are just going to start the reaction. So initially, there is no sulfur trioxide. So the rate of reverse reaction is 0 at the start. But the rate of reaction is increases or become highest after some time when we have more concentration of products. Beginning or at the start of reaction, we have lots of reactants, but there is no product, 0. And rate of forward reaction is high to form more products. And the rate of reactions are different, means forward reaction rate is different from the reverse reaction. After some time, after 5 minutes or after 10 minutes, more products are formed. So what will happen? The products will then convert back into the reactants. It means the reverse reaction will start. So the rate of forward reaction will get slow, and that of the reverse reaction will get started or become speed up. And again, now you can see the rate of reactions are different. Forward reaction rate is different from the reverse reaction. But at equilibrium state, what will happen? The rate of forward reaction will become equal to the rate of reverse reaction. So they will have same rates. If we draw a graph between time and rate of reaction, so you can see time means after like 0, this is the 0 time when we just start the practical. After 5 minutes or 10 minutes or 15 minutes, what happened to the rate of reaction? When the time is 0, or when we are just going to start the practical, you can see the rate of reaction, that is for the this is the reverse rate, and this one is the forward rate. You can see with the passage of time, or at when we start the practical, the forward reaction rate is very high. You can see the rate of forward reaction is very high, but the rate of reverse reaction is 0. At the start of practical, rate of reverse reaction is 0 because there is no product. Product concentration is 0. But when products are formed, what will happen? The rate of forward reaction will decreases, and the rate of reverse reaction will increases when we reach at a point when the rate of forward reaction becomes equal to the rate of reverse reaction, which is called equilibrium state. We can also explain the same terms in the form of another graph by plotting time versus the concentration of reactant or products, or amount of reactant and product. When we start the practical, you can see the concentration of product is 0, but with the passage of time, the concentration of product goes on increases and until it becomes constant. When we start the practical, we are taking some concentration of reactants. It may be, suppose we took 4 moles of the reactants, and when we treat them together, they are converted into products. So you can see the concentration of the reactant decreases, and finally it becomes constant. And initially the concentration of product is 0, and it then goes on increasing and finally become constant. So these straight lines shows that the concentration of reactant and product it become constant, and that state is called equilibrium state, when there is no change in the amount or no change in the concentration of reactants and products. In this graph, again, you can see that the concentration of two reactants, sulfur dioxide and sulfur dioxide and oxygen is high, but concentration of sulfur trioxide is 0. But with the passage of time, the concentration of product is goes on increases until it becomes constant, while the concentration of the reactant, these two reactants, goes on decreases until they become constant. So a state of chemical reaction in which forward and reverse reactions takes place at the same rate is called chemical equilibrium. Chemical equilibrium is also called dynamic equilibrium. Why is it called dynamic equilibrium? This is because reactions do not stop when they come to equilibrium state. The individual molecules keeps on reacting continuously. Although we cannot see those reactions with the naked eye, but they continue at molecular level. But there is no change in the actual amount of reactant and product. I told you that the concentration of reactant and product become constant at equilibrium state. So this means that concentration of reactant and product become constant at equilibrium state. We can understand the constant concentration by taking this another example. You can see we have reaction of hydrogen gas and chlorine gas. These two small white balls are for hydrogen gas, and these two green balls are for the chlorine gas. When they react together, they will form 2 moles of or 2 molecules of hydrochloric acid. So you can see when we start the practical, the time is 0 minute. This is just we are going to start the practical. At that case, you can see we have only white balls and green balls. White balls means hydrogen molecules and chlorine molecules. At the start of the experiment, we have only reactants and time is suppose 0 minute. After 12 minutes, you can see we have white ball with green ball. This white ball with green ball means this is hydrochloric acid. The white ball is hydrogen and the green ball is chlorine. So we have 4 molecules of hydrochloric acid after 12 minutes. After 24 minutes, the number of HCl molecules increases from 4 mole, it is now 8 mole, converted into 8 mole. It means with the passage of time, the concentration or amount of the product increases. Initially, the product was 0, then 4 mole, then 8 moles, and then after 36 minutes, the concentration again increases. From 8 moles, it increases to 12 moles. So you can see that with the passage of time, the concentration of product goes on increases and that of the reactant goes on decreases, because you can see the green and white ball, they combine together to form hydrochloric acid. So the concentration of the reactant decreases and the concentration of the product goes on increases. You can see from 8 mole we have 12 moles of HCl molecules now. But after 48 minutes, the concentration remained constant. There is no increase in the concentration of the product, 12 mole. And if you will check it after 50 minutes or 55 minutes, again the concentration will be 12 mole. So 12 mole, 12 mole, 12 mole, it means the concentration become constant. Now there is no change in the concentration of the product. This stage is called equilibrium stage, when the concentration of reactant and product become constant, not same. They are not same, but they are constant. Suppose concentration of the product of HCl is 12 mole, and suppose the concentration of the reactant hydrogen and chlorine is 4 moles. and 6 mole, but that of the HCl is 12 mole. They are different from each other, but they will remain constant. So this state is called equilibrium state. And as it continues at molecular level, so which type of equilibrium? Dynamic equilibrium. So dear student, hope you understand this lecture. Inshallah, we will continue the next topic in our next lecture. If you have any problem, you can ask through your WhatsApp group. Thank you.